Welcome everyone to Tech Talk Tuesday episode. What, Dan?
29.
29. There we go. We're moving up in the world. And if you're with us for the first time, because we have had new registrations to join us, you can catch all the replays on YouTube. The Baseline channel is Baseline Web Sales, Web Training, all one word, on YouTube. And all the previous episodes are there, along with all of the helpful tips that Dan's been producing, how to read error messages, how to troubleshoot the controller, how to find overcurrents, how to use soil moisture sensors. All these things are available on the YouTube channel.
I'd like to have anybody drop in the chat if they've actually gone to the YouTube channel and researched and found an answer that they were looking for on the recorded content that we've got.
Perfect.
So if you have, drop it in the chat. Let us know.
Yep. Yeah. And last week, if you are a distributor representative and someone contacts you with a question or support, you might go to the YouTube channel, find the video, and then send it to the contractor or the user, et cetera. I did that last week with a customer. They called me back 30 minutes later and they had found their Twowire overcurrent using the video that Dan produced. So it's very efficient and good use of all of our time.
Yep. And Stephanie, she's asked to repeat the YouTube channel once again. So that's Baseline Web Training, all one word. It's just go to YouTube in your browser, type that in. There's a dedicated page.
And what we'll do once we get started and when Dan takes it over, I'll grab the URL. I'll put it in the chat. You guys can click on it and then bookmark it. That might be helpful. So let's do quick introductions. We've got Chris Wright, VP of Sales for Baseline, myself, Andy Humphrey, Irrigation Technology Consultant, and Dan Conger, our Training Manager. And the topic for today is Twowire troubleshooting. And because our technology and our communication protocol is based on our patented Twowire technology, this tends to be a frequently asked question on many different levels. So we're going to cover a lot of it today. So with that, Dan, take us off.
Beautiful, beautiful. So I don't want to say we aren't going to talk about Twowire troubleshooting, but that's such a narrow focus. And what people are thinking, I'm going to go out, they're going to tell us how to work on the wire. And I want to really look at this holistically because we want to talk about a system. So there's three sections of the system I want to talk about. I want to talk about the controller itself, the wire path and the splice, and then the devices along that wire path. So I want to look at those three sections individually and then kind of talk about some of the tools that you have that are going to be different for each way. So I'm going to switch cameras. And then Andy, I think I'm going to want you to highlight me. So yep, there we go. So I've got my controller over here off to the side of my desk. Perfect. So one of the first things on the controller is, let's talk about error messages on the controller. So you'll either get error messages on the controller screen or on Base Manager, actually both if you're connected. Those are really valuable and you want to use those as much as possible. We'll talk about those again later on, but I don't want to start off with those as what I think is the most important thing. If you came up to a controller and you've got a dark screen, okay, well, we know I'm not going to see any messages there. So let's check out some of the things that are going here. So one of the things
I was wondering if you were going to have something up on the display, but that would
have been cool, but it's kind of unplugged right now.
This is the easiest one to troubleshoot, Chris. This is the easiest one.
Right. Is it plugged in? Does it have power?
That's excellent question.
All right, I'm cluing in. I'm getting into the groove.
So one of the things that we want to check then is there power, right? And to Chris's point. So my transformer, let's pull off my cover here so we can see what's going on. So my transformer is right down here. Is there power coming into the transformer? That's an excellent question. So is it unplugged? Is the circuit breaker tripped? Is there a problem with the transformer? So I could check high voltage and I could check the output voltage of the transformer. So that's an excellent thing to check on the controller. So power in and power out of the transformer. We got it, or do we not? There are some fuses on the board. So the Twowire board has some fuses, and I've got on here's a conventional wire board, and there's a couple of fuses underneath this cover that you can kind of see that when you pop off this cover. So you can check fuses on the controller. Also looking at the communication of the controller. So here I've got this particular controller has a cell modem module in here. Is that communicating out? And oftentimes a great solving issue for that, if you do have power, is to power cycle the controller. It's amazing how many problems that can solve whether it's a controller problem or a communication problem.
Or your washing machine for that matter.
I had
True
a experience this morning where my internet went out at my house yesterday, and then my controller this morning I noticed was not connected to the internet on Wi-Fi. So I power cycled the controller and it reconnected.
Boom. Right.
Yeah.
Right. It's amazing what they can do. I mean, even with I've had a cell phone and they're like, don't you start your cell phone? I'm like, no, I keep it running all the time. But power cycling your cell phone reconnects it and does some wonderful things. So a couple of ways to do that, right? So one of them is you could, if you're plugged in, you could just, unplug it and plug it back in, wait a couple of seconds, wait 5 to 30 seconds and then plug it back in. That works really well. You could hit the circuit breaker, but I've pulled off my protective cover here, and this little orange lead right here, by unplugging that from those leads, I think that for me, that is the absolute easiest way. The transformer is still powered up right here, but the power that continues on is been interrupted. So I think that is probably one of the easiest way to power cycle a controller.
Very cool. While you're there, and this is an afterthought, Dan, but the ribbon cable for the display is also part of that connection, right? When should you, if ever, disconnect the ribbon cable?
Yeah, I already disconnected my ribbon cable because I knew I was going to pull off the front panel. I only want to disconnect this ribbon cable after the power supply has been shut down, right? If you disconnect the ribbon cable from the display on the panel, very likely you're going to brick it, and that isn't a warranty issue, right? So if you got to remove this panel, which I did for access, power it down and then remove it, because you're going to need to remove the ribbon cable. Yep. Excellent point.
Yeah. So
cool.
Sorry, didn't mean to derail you.
No, it's spot on. That's perfect. So I'm going to move this off to the side. So the tools for checking this, really, I think the easiest tool to use is a multimeter, right? Or a volt ohm meter. And you need a set of leads with that. There we go. Here's my leads. So you can use this tool for a couple of functions. And the main function you're going to use it for is voltage, right? So this particular one can go to AC volts. Here's my AC volts. And I can check the power supply from my outlet coming in. I can check it from the transformer coming out. I can check it at various places. I can also check the power coming out of the board. So here's the 2-wire board back. And I can check power coming out of, let's get the right one. I could check the coming in from the transformer or coming out to the 2-wire path. I could measure that by putting my test leads on there. So the meter is a great tool for that. Or let's say we were doing conventional wire. I could do that exact same thing, test on that conventional wire board. So a volt ohm meter is great. You can also use it for resistance to see, do you have a complete circuit? And find out how your wire path looks, or any portion of your wire path. A volt ohm meter, I think, is the basic entry tool into doing any irrigation troubleshooting. I cut my teeth using these when I spent most of my time originally on conventional wire systems. So you can get these from anywhere from $10 to $200, maybe even more. So this is probably a $50 meter. So but very worthwhile. Okay, so this is what we're going to use in the controller and checking our power supply and checking some basic things there. You can also use this to check fuses. Yeah.
So we're talking about 2-wire troubleshooting today. I think we ought to just reiterate that, that 2-wire board as part of the controller, right?
Correct. I've removed it from the controller so we can see it. Good.
Yep.
Excellent comment.
So what should be the expected output on that 2-wire board when you're measuring it?
It's going to be, the static's a little different, but it's going to be less than 30 volts. Yep. Less than 30 volts. So, and then we have an input here. So that's going to be closer to 24 volts coming in, and then just under 30 volts coming out.
Yep. Okay. Just so we know what numbers we're looking
for,
right?
Right. And then those fuses are hiding underneath here, and I can use the resistance function of that to test a fuse. Now, just since we're mentioning fuses, this fuse on here, it says replacement fuse contact support before use. Well, it's not uncommon that we might come into a controller and open it up and look at it and not only find a couple of burned out fuses, but find a box of automotive fuses. So someone has they burned this fuse. Well, they burned the original fuse hiding under, burned this fuse, and then they had to go buy extra fuses, which is like, time out. What's going on here? A fuses pop or burn for a reason. There's something going on somewhere in the system. Let's address that. Fuses aren't the problem. You don't want to put in a bigger fuse. That's just going to make the problem worse.
That's a good point.
Yep.
Okay. So next thing down the line is the wire path. So first, let's just talk about two wire paths. So here I've got a little section of two wire. It's got an outer jacket of high density polyethylene. It's got a nice and tough to it, and two inner wires that are copper coated. And these are high density polyethylene as well. And then the other part of that wire path is a DBRY6, right? So I've got, these come with all the two wire devices. And there's the wire nut and then the waterproof capsule that goes in there. So this is these splices and the correct wire are important to wire path integrity. Right. So here I've got a completed splice, and it's coming along on my wire path, and this is just some maxi wire, but there are lots of different, we accept lots of wire on here, but this is a dedicated two wire. We're not reusing an existing number 14. It's the double jacket and the waterproof is really significant. And that's an important starting point.
i.e. it meets baseline spec, right?
Right on.
For performance. So if you're not using double jacketed, double insulated, solid copper core wiring, then, that does not meet our specification. So something to be mindful of. And don't ever use any kind of stranded wire for two wire as well.
Are you saying that from experience, Chris?
Yes, I am. Not that I installed it, but I've been on sites where that was used just as even a jumper from a controller to the field. An electrician used, stranded cable that was two wire paths, but that causes significant communication problems. So you got to make sure that it's solid copper cable. Okay.
So the device is then going to splice into that two wire path somewhere along in here. So this part of the device is still part of the two wire path. So we've got, the wire itself, the splice, and then up to the device. That's all still considered the two wire path. So there's a couple of things that can happen here. And we're just generally going to say poor wire path integrity is going to create problems for you. It may create communication problems with the device, because we've got that patented two-way digital communication where we're going to send out some information and then get a packet of data back, and it has to communicate back and forth. And any problems or any corrosion on this, not using the correct splice, it's going to corrupt that data, and we're not going to get good data back.
Yep, that's a good reminder, Dan, that voltage can travel through corrosion and communication travels through corrosion.
Yeah, and this is a drum that I beat all the time. A two-wire path is both a data path and a power path. So it's carrying data and power, where a conventional wire path is just carrying power. And I've opened solenoids with 18, 12 volts. So just as long as some power gets through it, solenoid will pop, but that's not true when we're saying.
And we should preface baseline two wire is like that. Not all two wire in the world is like that.
True. Yeah. Okay. So the tool for troubleshooting a two wire path is going to be a milliamp clamp. So this is a milliamp. A milliamp clamp is a clamp amp meter that can read down to 1/1000th of an amp. So 0.001 amp that can be read by this. Now, you may have an amp clamp that you use for checking motors or other things like that. Chances are it doesn't read down that far. So a milliamp clamp can read down to a very small unit. And this tool is going to be used to set to, there is AC amps right here. And we're just going to clamp. If we have an issue and we're going to try and track down the issue, I can use this to non-invasively clamp around a wire. And I didn't quite give myself enough room on the splice. I can just clamp that around here. So I don't have to break the splice, and I can find out what the draw is, what the amperage draw is downstream of my clamp. So if I may have a high amperage draw, like an overcurrent, and I can use this to test for that high amperage draw in an overcurrent. But what I think is the most important thing is I don't have to break these splices, right? So I'm preserving the splice. I'm leaving it alone. I'm not getting goop all over my hands. I don't have the expensive new splices. Go out there and check the splices. So milliamp clamp is the most important tool for this.
So 2 questions for you, Dan. One, if you've got a volt ohm meter and a milliamp clamp meter, are both of them necessary, or does the milliamp clamp meter do the same as the volt ohm meter?
That was like this perfect softball underhanded pitch. I love it. Thank you, Chris. So this meter does voltage and resistance. This meter does amperage, voltage, and resistance. So all I need is a set of leads. And now I have an amp clamp, a milliamp clamp, a voltmeter, and an ohm meter. This green device is only doing resistance and voltage. It's not doing anything for amperage for me. So for $50, you can get a great meter here. For $200-ish, you can get a meter that is going to, save you thousands of dollars. Hours, right?
Yeah,
right.
Potentially. Right. All right. And then question number 2, is there a video on baseline web training on the YouTube channel that goes into depth on troubleshooting a 2-wire overcurrent?
There absolutely is. Andy, you told us just earlier that you work with someone and you send them that video.
Absolutely. And they literally called me back 30 minutes later and they found the problem.
Yep. Are you dropping that link into the chat?
I'm going to get it and we're going to drop it in.
Beautiful.
Awesome.
Yeah.
All right. Yeah. Because we're not going to go into depth into how to troubleshoot an overcurrent, but these are the tools that are required in order to find a short that exists on the 2-wire path. And that short may be caused by a bad connection. It could be caused by a failed device. There's different things that would cause an overcurrent on any 2-wire path, regardless of manufacturer. These are the tools you need to do it.
Right on. Yeah. And the video does it. It's pretty detailed. It talks about the tools. It talks about what you need, what you don't need, and how to do that. So great. Okay. So next thing down the path is going to be devices. So here's the valve bicoder and here's a soil moisture sensor. So 2 different devices that are going to connect on the 2-wire path, although a soil moisture sensor can connect onto a conventional wire path. We're just going to talk about 2-wire today. So on devices, there, as Chris mentioned, there could be a problem with the device, right? And we want to rule that out. We want to find that out. Well, a milliamp clamp can get you so far, but let's talk about some of the things that might happen with this one. So one of them, there could be a problem on the 2-wire side, and that could be several different things that could be problems. There could also be problems on the solenoid side. So these are going to connect onto the solenoids wires. This is a 4-zone bicoder. So I've got a white common and then 1, 2, 3, 4 different wires that could connect to 4 different solenoids on this one. So any one of those solenoids, of those 4 solenoids, could cause an error, could cause a problem. It's not a problem for the entire system. It's just a problem for that individual zone. So it could be an open circuit, a short circuit. It could be the valve didn't work, different things like that. Mm-hmm. On the soil moisture sensor, we could have a moisture reading problem. We could have a temperature reading problem. And it could be because perhaps this blade got damaged by a device, or that the wire's broken. All right. Perhaps a tractor damaged this and it's allowed moisture into this one. So we can find that information out on this one. So the tools for that, to find these problems out here, essentially in the valve box or the end of the wire path, we aren't going to be using any of this stuff, right? We're not going to be using any of these tools. The number one tool that we're going to use on this one is the controller. Just knocked my wire on the ground. It's going to be the controller.
Everything okay there?
I got a bunch of crap strewn on my desk here today. Yeah, the controller will give us error messages and tell us what's going on. So we'll look at those in a minute. It would tell me if I have an open circuit on the second zone on this one, or a short circuit on the fourth one. It'll give me information, or it might tell me that I'm reading temperature but not moisture content. There's a problem with this device. Or it might tell me that there's a communication error or a wire problem here. Lots of information that will come with the controller. So controller.
So you were pointing at specific places on that decoder, right? What do we provide on the decoder that can help us troubleshoot?
Oh, let's bring that a little closer. We've got there's actually 5 LEDs. So I've got 4 LEDs here on the solenoid side, and then 1 on the 2-wire side. So there's actually what we call a blink test you can do. So I could do a blink test, and that would tell me, it would blink and tell me the 2-wire is working. Or when I test or activate this zone, the particular light will light up on this one. So I could find out if I have a problem on the 2-wire side, or if I have a problem on the solenoid side, and I can tell that just from the lights.
So if it's the LED on the 2-wire side is blinking, what's that telling us?
That's telling me that up to the 2-wire path all the way through to this side of the bicoder is good, that I have a connection through. It's able to communicate with it, but it may not be able to open a solenoid or activate it for some other reason. It could be a bicoder problem, or most likely it's a wiring problem on this side.
Okay. So if that 2-wire side LED is blinking, is that telling us that we both have power and data communication?
Ooh, I don't know. Clarify that for me. I know it tells me we're having power. I think it also tells us we have communication. And would you turn that into a statement for me?
Well, if you've got power, if it's blinking and you've got power to it.
Of course, we know I have power.
Right?
Sure.
Then a way to test if you've got communication or data would be to go to the controller and do a self-test for that device based on the serial number that's associated with that decoder. If it comes back and it sees it, then you have data as well.
Mm-hmm.
Okay.
And it could be too, there are times when the data could reach the decoder, but it can't come back. So not to complicate the question, but the signal could hit the decoder, turn the valve on, may not make its way all the way back.
Right. Yep. So to Chris's point there, here's how we can use the controller. So we can look at the error messages that are going to come up, and which we're going to look at in just a moment. So maybe a very specific message about this serial number, about this device. The other thing we can do is test this device, and I can test the device from the 2-wire side, and from the solenoid side. I can test both of it and get information about it.
Yep.
Okay. Exactly. So here's an error message that you might get on the controller, or you might get through Base Manager. And this is exactly what I covered in a series of messages and alert videos. So this one is device valve decoder open circuit, zone 9, E288171 is a medium priority. It says valve failure, an open circuit solenoid, unable to operate this valve, and bicoder E188171.
That is a lot of information provided at the controller for a device, right? Date time stamps it. It gives you a priority. So in understanding what the priority messages are will help you understand what the behavior is going to be going forward. And then it tells you pretty specifically what the issue is.
Yeah. So let's unpack that. So this is saying that zone 9 and E188171, they're associated, they're assigned back at the controller. So zone 9 had a valve failure because of an open circuit solenoid. But more importantly, if we cut to the chase, it didn't operate this valve. So zone 9 didn't run. You know that right away. It confirms the serial number on there, and it tells you why it didn't. So it was an open circuit solenoid. So what's some examples of an open circuit solenoid?
Yeah, well, the key word there, Dan, first of all, is solenoid.
Yeah.
We're not seeing the word 2-wire or similar. We're really seeing solenoid. So that should kind of tell you where to go, just with that word alone.
Yeah, going to the valve box.
This isn't the decoder this is the solenoid, right?
Right.
So start at the solenoid.
So not a 2-wire issue, but it's the solenoid side of the bicoder. So it could be several different things, right? So it could be a splice on there. It could be the solenoid. Those are probably two of the most common things. Maybe you extended the wire and that wire is there's a problem with that one. But essentially you're going to open the valve box. Now, for this particular message, I'd probably bring my multimeter if I didn't have a milliamp clamp, but I'd be using the resistance function of a meter to measure my solenoid and to inspect my wire splices out there. But this tells me exactly where to go. The other thing about this one is the E288171. That's a 2-zone bicoder. So there's another one. It could be 170 or 172, one right above or right below it. Could have a problem or maybe not, but it could tell me information about it as well.
Exactly. So
Cool.
basically, open circuit means that, there's not a continuous loop of electricity flowing through that from decoder to solenoid and back, right?
Yeah, exactly. Well, if I install
a wire on the solenoid, one of the wires or both the wires are disconnected from the decoder.
Yeah. Or if I installed a 4-zone bicoder and only attached 3 zones to it, that fourth one would throw that same message as soon as it tried to run it. Yeah.
Yep. So how do you avoid those messages, Dan?
Just go in and unassign that fourth one.
Yeah, don't assign it to begin with.
Yeah,
exactly.
Which happens a lot on the conventional wire boards, right? People will get those error messages and just become immune to them. So we want them to pay attention to them. So here's another one that's a little harder to work on, but it's important to know. Device 2-wire no response. Zone 13, E188171 is a high priority. 2-wire communication failure, unable to talk to this device. So this is all about communication on the 2-wire path out to zone 13 or that particular serial number. Mm-hmm. So somewhere along that 2-wire path, it's not able to communicate properly with zone 13.
Yeah. So if we unpack what that message is, unable to talk to this device, what does that indicate, Andy?
If you think about when we run a search and assign, the controller's going out, communicating with the device, and that information is coming back. In this case, it's going and saying, hey, where are you? Where are you? Where are you? And it's not able to, that device is simply not connected to the 2-wire. There is a broken wire, missing splice, something like that, where it can't communicate with the device.
Yep.
Or it could be the controller talked to it, but it's not communicating back. So it's only having one-way communication. And that comes from corrosion, right? So if you've got a corroded splice or a nicked wire that's interrupting it, because again, 2 wires of data cable first. And if that if that data cable doesn't have good integrity, the communication is going to be garbled.
Mm-hmm. Yep. So again, keyword there being 2-wire, right? In order for us to even check the solenoid, first it has to communicate with the decoder. Once it communicates the decoder, then we can reach the solenoid. In this case, we can't even reach the decoder.
Yeah. Right. So you spoke earlier about this blink test capability. Mm-hmm. So how can I find out if that decoder is being seen by the controller?
So at the controller, there's a test dial position, and you can do a test all devices or test just a single device. Now, in this case, you could just test zone 13, the E188171, test that one and see if we get a response. And chances are it's going to repeat that. Now, if that message went away, if you got the error message on base manager and then the message didn't come back, intermittent messages, there's a reason why they're popping up. So it's probably going to come back again if it didn't come up during the test.
And sometimes I recently saw this where there wasn't enough of a short on the 2-wire to flag an overcurrent, but there was enough of a short on the 2-wire to cause communication error. So every time the user did a test, all different decoders were coming up with errors, which is just a sign that there is something happening on that 2-wire path.
Right.
Exactly. So you can do a blink test, go out to the box, see if that decoder or that LED is blinking on the 2-wire side with that decoder, which will help you understand a little bit better what the scenario may be. So you can then dig deeper to find out what's causing that communication error.
What's kind of cool about the blink test is if I have an unskilled person on site, I could run that remotely and have them report back to me. I don't even have to be on site. So someone else can do that and give me a visual indication of what's going on.
Yep. So Craig asked the question, what about damage on a moisture sensor blade using Twowire or causing a Twowire overcurrent, right? So that's creating a short in the Twowire path. And the method for finding out how to resolve that is explained in the Twowire overcurrent link on the YouTube channel that Andy dropped.
Yep. The moisture sensor is just like any other device. If they short, they all short in the same way and cause that overcurrent.
Yep. Mm-hmm. All right. We're 2 minutes past our bottom of the hour.
Nerds are talking. Yeah.
We're running overtime today, but I think it's good content and good discussion. And I like it as more of a deep dive, but again, let's encourage everybody to, review the website or review YouTube. And there are so many answers that are available on that. There's a lot of recorded content that Dan has included over the last few months since, our lockdown scenario that can really help you get answers that you need, on demand without having to call into tech support. Right.
Yep.
So some of them can be, self-solved just by using the information and the resource that's available to you.
Yeah. And kind of on that note, I think, Dan, sort of one of the takeaways from today that we talked about just a little bit before the show was that the messages really matter. And if you take the time to look at some of those keywords that are hidden in there, like the word solenoid, like the word Twowire, they can help point you in which direction to go. If you're not exactly sure what the message means entirely, those keywords can point you there.
Yep.
Right on.
Read the messages.
Read the messages and use your stickers. Right.
Nice.
All right, everybody. Thanks for joining us again today. Next week, we are going to take a break because we've got a conflicting distributor rally that we are going to be hosting virtually. So we will be back on what's the date?
31st. 31st.
With another episode. So look for us then. And if you're a distributor and are able to join the rally next week, please do so. Should have received an invitation for that. And we look forward to continuing to provide you with good information to help you operate your system. So with that, we'll say adios.
Yep. See you guys.
Work hard. Have a good week. We'll talk to you later.
Bye.
All right. Take care, all. Bye.